7.4, we're going to finish up 7.4 today, talking about percent. In particular, we left off with a last little bit that's talking about interest. So we're going to flip over there to that portion and take a look at some interest applications. Interest is the amount of money that you pay or earn when you borrow or lend money. So if you've got a car payment, right, you've borrowed money for your car. So the interest is the amount of money you owe. If you put the money in the bank, like as a savings account or something like that, then interest is actually the money that you have made by lending it to the bank. Did you know that's what you're doing when you put money in the bank? You are. You're lending it to the bank. It's a safe bet, right? But you're lending it to them. They take your money, they lend it out to other people at a higher interest rate. That's how the world works in finance. Principal is the amount of money that you actually either loan or borrow. So it's the original amount. And your interest rate is the percent that is used to determine your interest. And it is a percent. Notice that. So there are two formulas for simple interest. They're not two, really. It's just one, and one that's been reworked a little bit. So simple interest is P. That's P is your principal. Okay, so that's principal P. Plus the principal times the interest rate. This R is your interest rate, and you have to use it as a number. So if it's 5%, then as a number, that's 0.05. And then the T is time. Right? And the time is always measured in years with this application. Okay? When we're talking interest, we're measuring things in years. So if it talks about an 18-month loan, then it means that you've got 1.5 years. If you take a look at the second version of this equation, all that they've really done is they've factored the P out in front. Right? And if you think about it, it might be easier to think about what happens if I distribute the P through, I end up with the other equation. So they're just two different versions of the same equation, really. Right? This formula is slightly different than the one that's shown in your book. You should know that. I think that's in your notes. I don't know that I think I might have accidentally deleted it in my slides when I was revamping some of these slides this semester. They use a slightly different formula, I believe. So let's take a look then at some applications of interest. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. How much interest will the company be charged if they are charged 13.5% compounded monthly? So we can use either version of this formula. Do you guys like the first one or the second one? First. Okay, we'll use the first one. So the formula that you've chosen to use is A equals P plus PRT. Okay, so P, principal. What's the principal in this problem? Bigger. It's $320,000, right? It's really large. Do you see the $320,000? Remember, principal is the amount you borrow or the amount that you lend. Okay? So $320,000. So this is $320,000 plus $320,000. Okay, times R. What is R? It's the 13.5%. So how would I write 13.5% as a number instead of as a percent? Right. The decimal moves 2 to the left. This is 0.135. And I will multiply that by the time. How long is this loan for? 18 months, but time must be measured in years. So what will T equal? 1.5, or 1 1/2, exactly. Okay, so this is what we have. If you want to grab your calculator for me, Let's figure out what answer this gives us and then interpret that in light of the question we were actually asked. All right, what do you guys get? It's big. It's got to be more than the 320, right? Wonderful. $384,800. So let me take one step back because I didn't define for you what A was over here. I just skipped right past it. The A here is the amount after T years. So it means the amount of the investment if it's like something you've put money in the bank, or the amount that you've paid if it's a loan you're paying off, the amount you've paid or invested after the length of years is over. So this $384,800 is not the interest. It's the total amount they have to pay back. Are you with me on that? They borrowed $320,000. They have to pay back $384,800. Okay, but $320,000 of that was the original amount that they borrowed. That's not interest. So how could I find out what the interest is for what they paid? Right, it would be the $384,800 minus $320,000. So how much is the actual interest value that they owe back? Yeah, $64,800. All right, any questions on that one? Okay, I want to show you an interesting application that kind of ties this idea of percents together a little bit in this section. Because of a recession, the value of a new house depreciated 10% each year for 3 years in a row. Then, for the next 3 years, the economy began to recover and the value of the house increased by 10% per year. And I don't know why it's missing. My question's missing. This is what happens when you edit things. Okay, so my question that's missing, I'll put it over here. Question A is, did the value... Yes.
On the last problem, there was a second question about like compounding monthly rather than annually.
Is it still in your notes? Mark it out. The compounded monthly one was supposed to be pulled out. The compounded monthly is something they changed in this section. It used to be in section 7.4, and they just took it out of the entire book. Like the entire book does not have compound interest, which I'm not entirely comfortable with, I'll be honest with you. But unless I supplement you with additional materials, I don't have any questions to give you either, because the book has no questions about compound interest in it. So yeah, thank you, Emily. Okay, here's the question that's missing from my slides at the moment. Did the value of the house increase or decrease after the 6 years? Okay, does that match with the question that looks like on your paper? Wonderful. All right, so I had a very interesting conversation. My son, some of you know him, Temeskin's in a personal finance class. Have you guys taken personal finance here? Or is that something education majors don't do? They don't? Okay. So he's taking a personal finance class, and we've done lots of personal finance stuff in our home with our children too. But we had a very interesting conversation that he asked me, and he was under the assumption that some of you also may be under, that houses always go up in value. It's a great investment. You should buy a house, you should buy a house, you should buy a house. And the reality is houses don't always go up in value. We actually got caught, my husband and I specifically, when we moved from Ohio back to Oklahoma. We bought the house for $165,000, and then the recession hit right afterwards, and we sold the house 3 years later for $132,000. It's a big hit to take. Huge, right? So houses do not always go up in value, and that's what this problem is actually talking about. So there's a recession, and the house is depreciating 10% each year for 3 years. But then the economy recovers and it appreciates. It goes up in value 10% per year for 3 years. So one of the things to look at in this question is, do those 10% just cancel out? Decrease 10%, increase 10%, back where we started. Is that how it works, or is something else going on? Now, you might notice in this problem, they don't tell you how much the house is worth at all, right? There's nothing here that says how much it's worth. The reality is that it doesn't really matter how much it's worth. The percentages will work the same way whether the house is worth $50,000 or $250,000. So, because of that, you can actually set an arbitrary amount for the cost of your house or the value for your house to work with the problem, because in the end it's all going to not matter, because the percents would have worked the same way no matter what you chose. So the percent or the value of the house that I like to start with, because I think the math with it works out cleaner, is just $100,000 for a house. You guys good with that? Okay. So we're going to say that our original house is $100,000. All right, so it's a $100,000 house, and I know that we've been using a lot with proportions, and we could use proportions here as well, but I want to show you another option, and many of you, of course, have been wanting to use this option anyway. We're talking about the house going down in value initially. So if the house is worth 100% this year and it goes down 10%, how much is it worth of the original 100% next year? Not value, percent. 90%, right? If it goes down 10%, it's worth 90% this year, or the following year. So if I take, this is after year 1, I have my $100,000 house, and it's worth 90%, I can multiply that by 0.9, right? That's 90% as a decimal, 0.9. How much would I have for the value of the house then after year 1? What is it? Not 900. Oh, I didn't. 90. Yeah, that's okay. Well, it would be fun if it were worth 900,000. Let's go with that. But it's unfortunate not. It's worth 90,000. Okay? So we no longer have a $100,000 house. We have a $90,000 house. So in year 2, when it goes down another 10%, it's going to go 90. We're going to multiply by that 0.9 again. But we're not going to multiply the original value by 0.9. We're going to multiply 90,000 by 0.9, because the house is no longer worth $100,000. It's worth $90,000. So what is 90,000 times 0.9? $81,000. So this is after year 2. Okay, so far I've done it for 2 years, and for 3 years it's supposed to depreciate. So what will my next line of math look like? 81,000 times what? Times 0.9, right. And now the house is worth how much? 72,900. Okay? This is the point when people are bailing because they're freaking out, right? The house has lost so much value, and if they bail right now, they're going to lose a whole bunch of money. Agreed. We weren't in a position where we could choose. In our personal case, we were moving like out of state, so we couldn't just, not sell the house. We got to get it moved on. But this family is sticking it out. And the next year, it's going to increase by 10%. So now they've got a $72,900 home, but it's increasing. So it's not going to be multiplied by 0.9. Any idea what it might be multiplied since it's going to increase by 10%? 1.1 is right. Yeah, so 1.1, just so that you can see where that's coming from, 1.1 would be 110%, right? Multiply it by 100, you get 110%. So yes, 72,900 times 1.1. How much is the house worth after year 4, sorry. 80 what? 80,190. Great. So year 5 looks just like year 4, except that it's starting at 80,190, and it's going up by my 10%. And what do you have? 88,209. We're almost done with all of our years of change. I now have 88,209 that I'm multiplying by 1.1. And what do I get?
97,029.
Yeah, let's just round it a whole dollar. So let's go to $30 at the end. It's not going to change enough for it to matter beyond that. Okay, so the question asked, did the value of the house increase or decrease over the 6 years? It decreased. Now, it would not be appropriate for you to say it decreased by and tell me what the difference in 100,000 and 97,030 was, because we made up 100,000, right? We made that number up to begin with, but it decreased, and no matter what number we picked, it would have decreased. The kicker is it would have decreased by the same percent, and that's what Part B wants to know. Well, then by what percent did it decrease? Well, we started off, again, at arbitrary $100,000, and we ended up at 97,030, right? That's what we ended up with. So how much money did we lose in value of this house if I started at $100,000? What does this give me? $2,970 lost. Nowhere near the almost 30 grand that happened in the middle of it, right? Or 28 grand or whatever it was. But it's still less than what it was at the beginning. And it's wanting to know what percent that it actually lost. So we've worked with proportions, and you guys hopefully have done a little bit of the homework in this section. And we've talked about the fact that percentages can always be written as a value over 100, and that's exactly the portion of this problem we're looking for, is what percent. So we lost $2,970 in value. And what was the original value of the home we chose? 100,000. So if you chose something besides 100,000 here, your numbers would be different at this point on the numerator and denominator on the right, but the percent that you'd end up with is going to match exactly the percent we end up with on these numbers. So if we cross multiply, I have 100,000 x equals 297,000. What percent do you get for what was lost? This is a percentage that was lost. 2.97%. And it will work out that way no matter what.